No. All right. Yes, I was saying that the examples make it help make more sense, okay, than just looking at it theoretically. Just for more detail on probability of failure on demand, okay. It is useful when demands for a system are intermittent and relatively infrequent, okay. It's appropriate for protection systems, for example, where services are demanded occasionally and where there are serious consequences if the service is not delivered. Okay, so protection systems, for example, so intermittent, they just mean it's required and then not required for a while. Okay, required and then not required for a while, off and on. Okay, and relatively infrequent. So that's the probability of failure on demand. So it's not that they all work for one particular type of system. Different systems need work better with the different metrics, or you can get a better picture with a different metric from different systems. Okay, that's what they mean there when they specifically say that it's for that kind of system. Okay, then the rate of fault occurrence, rate of occurrence of the faults. The example they gave there was 2 failures are likely to occur every 1,000 operational time units. I said I won't explain the time units. Okay, but this one is relevant for operating systems, transaction processing systems, where the system has to process a large number of similar requests that are relatively frequent. So you can see the difference here. The other one is a large number of similar requests that are relatively frequent. They give a very good example there of the credit card processing system, one airline booking system. So these ones are going to happen frequently, okay, and they are similar. Okay, so remember that the different metrics are more appropriate to different kinds of systems. Okay. Because now, if it's now like imagine a security system, the one that a protection system here. So remember, you're requesting is probability of failure on demand, because you're going to you need the help from the protection system at a particular point. Okay, but then here the people who are using the credit card systems or the airline booking systems, it's about failing at that particular moment. Okay, so I hope you really get the difference, that you cannot have the same metrics operating the kinds of, okay, you cannot have the same metrics quantifying the same types of systems. Different types of systems will work better with different metrics. Okay. Measure of the time between observed failures of the system and is the reciprocal of the rate of occurrence of failures. So if you can go back to this. So the MTTF is a reciprocal of ROCOF. Okay. So if you have one of them, then you have the other. Okay, hope you understand that. I was just showing you in the table there that it's those two are reciprocals of each other. Okay, the ROCOF, which is the second one, and the MTTF, which is the third one there. They're reciprocals of each other. Okay. Sorry, yeah, it's here. An MTTF of 500 means that the mean time between failures is 500 time units. And it's relevant for systems with long transactions. That is where system processing takes a long time. Okay. The example they give there, computer-aided design systems where designer work on a system for several hours. And what process systems? So you don't expect these systems really to fail. I mean, you're designing something. You don't expect to have a problem with your design system. It will take a very long time. So this is why this one is more appropriate for it. You're not going to use rate of failure occurrence yet you're not expecting many failures. That wouldn't make sense. It would be better to go for a metric like mean time to failure, because you're going to expect such a long time before failure occurs. Just hold on a second. Yes, sorry, just something held me up there. And then the availability. So availability is one where I found a good example. Okay, the measure of the fraction of the time that the system is available for use, and it takes repair and restart time into account. Okay, that example we read it for you. But then if you go to that you'll find those textbooks definitely. But if you go, let me share with you the page. Okay. Yes, so this is page 323. So the example they give for the availability is, for example, the telephone switching systems are the best example for availability. Okay, but just look at just look at the availability figure, 0.9. So you may think availability of 0.9 is really good. Availability of, this is out of 1, by the way, or availability of 0.99 is really good, or availability of 0.99 is really good. But then you'll be surprised now, like you can start from the bottom, 0.99999. So the system is unavailable for 8.4 seconds in a 24-hour period, roughly 1 minute per week. When you multiply by 7 and convert it to a week, that's an availability of 0.999. Okay, but then the same metric, when it is 0.999, you have now 84 seconds in a 24-hour period when the system is unavailable. Then 0.99, you have 14.4 minutes in a day when the system is unavailable. That's actually it's unacceptable when it comes to telecom switching systems. Then you have 0.9, where you're going to have the system is available for 90% of the time. That means it's unavailable for 10% of the time, 144 minutes in a 24-hour period. That is actually unacceptable. So, but then you can see these metrics. You can see their purpose and their importance. It really gives you a picture of the system and how it's working. And they work for particular systems. Don't forget that. Okay. The best for telephone switching systems is availability, because it will clearly show you how the system is performing. And maybe for real life example, I remember when working on some projects for MTN South Africa, the availability, which was going beyond 0.9, going beyond 0.97 was already a source of trouble. Going below 0.97. Okay, so these metrics are important. They really give you a picture of how the system is working, and of how this definitely helps the business in the end. Okay, depending on how you see how the system is working. Okay. Great, I can just remove this. So those textbooks will be helpful. They will be helpful. Okay. I will just once again go back to share the PowerPoint. Some of you have the PowerPoint. No, it's particular, no, but it's okay. You'll access them. Okay, so that's about the metrics mostly. I already talked about the non-functional specific non-functional requirements. Okay, I just explain them further, and different kinds of faults. Okay, the different kinds of faults they actually explain here on the next page there. Classification. So failure consequences, they also just try to explain more here about failures. When specifying reliability, it's not just the number of system failures that matter, but the consequences of these failures. Okay, so just know that failures are an important topic when it comes to talking about reliability, because whether you have the non-functional or functional reliability specification, as we have seen in the definitions, failures come in both cases. Okay. Okay, so they're just really specifying more about failures because of how important they are when it comes to reliability specification. And there they just talk about different classes of failures and their descriptions. Okay. Here in a summarized statement, they talk about the steps to reliability specification. Remember, we've been having steps to safety specification, security specification, okay, and risk analysis specification, risk-driven specification. Okay. So here they just say for each subsystem, analyze the consequences of the possible system failures. Okay. From the system failure analysis, partition failures into appropriate classes, okay, of which we have seen the classes of failures. Okay, they are really just straightforward there as they're defined. For each failure class identified, set out the reliability using an appropriate metric. Okay, remember, as I told you, the metrics are for particular systems. Okay, and particular systems face different kinds of failure. So you're not going to have, that's why they're saying here, an appropriate metric. You're not going to just choose any metric for any system. Okay, different metrics may be used for different reliability requirements. Yes, it so happens that some systems find you can use different metrics. Okay, it's not really a must that you must stick to one particular one, but remember that some are better suited to to different. Some are better suited to some systems. Okay. And then lastly, identify the functional reliability requirements to reduce the chances of critical failures. Okay, so yeah, they just summarized them. I know the other ones were more listed out and then explained, but here it's just a summarized form. If you've been understanding the different steps for the specifications, then this one also is easy to understand really from the same general overview. Okay, this is just an example of a bank auto teller system. And then they talk about the reliability specification for an ATM here. They're really just going more into an example. Okay, it's more into an example. So that example you can look through and try to analyze, but it's really just going through more into an example. Okay. But then the important, just for better understanding, I wanted to talk about the time units. These time units they talk about, okay? So there are different kinds of time units for different types of systems. Okay? Remember, when you understand better, it will be better for you to really recall some of these definitions. So the time units, you can have different time units for these systems, okay? They can be calendar time. Okay, calendar time is the time that we follow every day. They can be processor time. Okay, is someone saying something there? No. They can be processor time. Okay, or they can be discrete units. For example, number of transactions. So even a number of transactions can be taken as a time unit. In that case, I may put time in quotes, but number of transactions. So just have that in mind. When they're talking about these time units, you can have calendar time. That's like the normal time. You can have processor time. Okay, or you can have discrete units such as number of transactions. Okay, so depending on the kind of system that is being used, the time unit will then be determined. Okay, the time unit will then be determined. For example, in systems that spend much of their time waiting to respond to a service request, for example, telephone switching systems, the time unit that should be used is processor time. Okay. But if you use something like calendar time, it's going to include the time when the system was doing nothing. Okay. Instead, a time unit like calendar time should be used for systems that are in continuous operation. Okay. And then monitoring systems such as alarm systems and other types of process control systems also fall into this category. Okay. But then systems that process transactions such as bank ATMs or airline reservation systems have variable loads placed on them depending on the time of the day. Okay, so this is where you're going to look at number of transactions, for example. In these cases, the unit of time used could be the number of transactions. Okay, so that's just to give you, to open up your minds more on the time units. Okay, to open up your minds more on the time units. Okay, good. So here really this is just really extra information. It's impossible to empirically validate very high reliability specifications. Okay, just really more information and analysis. Okay, that one you can go through. Okay, so the key points we have been looking at, risk analysis is the basis for identifying system reliability requirements. Risk analysis is concerned with assessing the chances of a risk arising and classifying risks according to their seriousness. Okay. Security requirements should identify assets and define how they should be protected. Reliability requirements may be defined quantitatively. Okay. And reliability metrics include, we have seen probability of failure and demand, rate of occurrence of failure, mean time to failure, and availability. Okay. Non-functional reliability specifications can lead to functional system requirements to reduce failures or deal with their occurrence. Okay, so those are just the different points that we have. That's a summary really of what we have been going through. Okay. All right. So I'm going to hey, permission to, oh, sorry, I didn't see this. Permission to record again. Oh no, I think I give you permission. Okay, so this should be fine. I will continue to share with the woman whatever I have, and then he will confirm if it's already on the link that I think it's Moses who shared, then there's no need to share it. Okay, if it's not on that link, then he will share it with you. That will be fine. So for the assignment, just to the instructions are there, but just to emphasize the date of handing in. Let me check what I wrote on the date of handing in. I don't say different date. No, it's not opening. Okay, first of all, definitely we're going to attempt all questions. Okay. The work is to be done in groups of 5 students. I don't really know how many students you are in total. I don't know how many students you are in total, but according to the approximate number I was expecting, I want you to do the work in groups of 5.
Excuse me, sir.
Yes.
I've so far got only 8 students who have inboxed their details, but I'm seeing 15 participants, so I don't know the other remaining.
Oh, you have so far only 8 students in total?
Yeah.
Okay, no problem. I'm sure that once they know the assignment is there, they will confirm. What I can do is this. By today is what? Today is Wednesday. If they can, this Wednesday. If they can, okay, let's have this, because today's Wednesday, they can confirm through the whole of tomorrow, they can confirm. Okay. Okay, just please, in case you're going to do the course, just inbox Davis. Okay, as he has told you there, inbox him on WhatsApp, so that he can, because it's tomorrow, by the end of tomorrow, he's going to forward me the number of students. Okay. Yes, and the number of students according to the number I was expecting. I wanted to do groups of 5, but depending on what he sends me, I may change. Okay, but in the meantime, I'll keep it to that. In the meantime, I'm just going to I'll need to send the assignment to Davis. I'm going to send the assignment to Davis, and then Davis will, by the end of tomorrow, he will have confirmed the number of students, and then we shall see if I should change it or not. But for now, let's keep it. I'm just going to keep it to as it is. Groups of 5. Please begin on the assignment, because I don't want it to be I don't want it to be handed in late. So for now, groups of 5, begin the assignment. Depending on what he sends me tomorrow, we shall I may change the number of people in a group. Okay. And then the work is to be done. Late submission will lead to loss of marks. Then, of course, if I get your work late, you lose marks. Okay. The deadline for submission is 3rd December. Okay, it's 3rd December. That's the deadline of submission. Then I'll also confirm on Friday when we shall have our first cut. But most likely we're going to have our first cut in the first physical lecture. Okay, and the first physical lecture is on the 1st of December, right? Yes. Yes, Davis, you begin your lectures after this physical lectures next week, right? Hello, Davis? Davis?
Yes, next week shall start physical lectures, sir.
Okay. Next week. So I will confirm on Friday, but most likely the first cut we are going to have it on the 1st of December. I'll confirm on Friday. Yeah, so that's it about the assignment. Let me just after here, I'm just going to forward it to Davis. Yeah, so please, if you can just be after the week of assignment. After the week of assignment. Okay, let's see. I'll give it consideration. I will update on Friday. Okay, I'll update on Friday. Let me see. Because I don't want to delay many of these things. You know how first of all, we're getting into December, and then you have exams beginning of January. And then you people have been having backs and forths about your work, about your whole education, about the whole education system at the moment. So the more we delay some of these things, the more problematic it gets. But if we have a chance of physical lectures, we can maximize and use them accordingly. So let's try not to delay any of these things. So there's the assignments, there's the tests. Okay, but it's okay, Andrew. I'll update on Friday. I'll give that consideration. Okay, is there any other query? Okay, no other query, I think. So I guess people are still deciding which elective to do, which one not to do, but please try to decide quickly so that you can, just for your own good. And for me as well, who's going to be marking and all. Just for your own good, please make up your minds quickly, and then you move on with the semester. All right, we can let us stop here. I'm not going to begin a new one now. You can stop here. If there's no other query, please, you can let us know like this. If there's any query, if there's no other query, then we shall end it here. All right, no other query. Thank you so much. Have a wonderful afternoon. Let me send Davis the assignment now.